So we're going to take a look at the second part of Module 2 and just give you some more overview of in this situation of installing the Linux system. We're going to talk a little bit about file systems, about volumes, and also about the parts of the terminal shell. And I'm just going to give you this is going to be heavy on some demonstration. So I want you to just kind of see more about how this Linux looks, and we're going to do some good hands-on stuff here. And most of all, I want you to practice on your own system a little bit. So there's some terminology that we'll talk about here from the PowerPoint, uh, and this is the difference between a file system and a volume or a partition. So one of the things that you'll see often is the term disk partition, and this goes back to the days when when there were hard disks and the hard disks were physical. So I'm just going to show you really quickly uh, kind of the difference here between what may be your Windows system and something else. So when I go in my Windows system and I look at my drives, uh, these are specifically physical drives. Now, in a server environment, that may not be um, it may not be purely a physical drive. It may be a logical volume that could span drives. But in this case, on my personal machine, this is a physical drive. It means I can open the case, I can touch this thing, I can take it out, and I have formatted it. Now, the formatting of the drive so that it can store information, that's the partition. I can choose, if I were to choose, for instance, to take this physical drive C, and let's say I wanted to break it up into two logical volumes, um, then it would still be the same physical disk, but it would be broken in half. So Windows would show it as two drives, maybe a C and a D. One would be the primary drive, mainly because it would be the boot disk, but also because it may be physically located on a controller, on a primary controller on the interface board. So now in this particular case, this is the SD card, and right here, and it is listed as D drive. Now that is an actual physical card that's inside my computer. Now, the one thing that differs about Linux is that it doesn't have driver letters. So Windows is the only system that you're going to see where that has driver letters. Any Linux uh, system, Unix system, or Mac system will not have those. So just to show you real quick um, what that partition might look like, I'm going to run and just take a look at my virtual machine, and we're going to start we're going to look here. Now remember, the virtual machine is a computer that's a simulation. So it's software simulation of a machine. And as we can see, when I look at the settings on this, I'm emulating hardware. So in this case, when I go to storage, I have two separate storage devices, a SCSI disk that has a file associated with it. In this particular file, this is my device, or it emulates my physical disk. This is my volume. And it actually maps to a file. And you can see that right there when I hover my mouse over it, it has the C drive. So it has that actual file that is my partition. And this particular one right here is another virtual disk that I created, and I plugged it into a virtual USB drive. It was just like I had a computer and it had a hard drive on it, and then I went and plugged in a I went and plugged in a USB drive for some spare storage. Okay, so that's kind of what that emulates here, and I'm going to go ahead and start that. And we can watch this machine boot up, so we're going to be able to see that, and I'll show you how to go back and kind of look and see what happened here during this boot up phase. But it's going to begin to, most of this information that's listed here is all for debugging purposes. When the numbers that you see on the left-hand side are actually timestamps, so that if I replayed this or look back at it, I can see what's going on using a timestamp and see where we are in the boot up process. So now I have my login. I'm going to go ahead and log in. I like this little distribution because it's small and it's lightweight and it boots up quickly. When we log into this, we can see here that I'm looking at the Ubuntu. This is the distribution. This is the major revision and the minor revision, 4.7. LTS stands for long-term stability. So this is a revision that is going to be made and have a very long support life cycle. So they're not going to do a lot of updates on it. So this is the architecture, and this is the Intel architecture. It's the 8086 x86 architecture with the 64-bit. So that kind of gives you an idea of that. And if you watched the previous video, you remember that uname A will give you some of that same information with a little more stuff. So that is, here's our command prompt. And I want to show you, and again, there's no disk drive here. We just have the root drive, and there's no, sorry, I said there's no disk drives. I meant there's no drive letters. So in this case, we just have a device, and then actually the A and the B. Here's my main partition. It's the 8 gigabytes, and here's the small one. It's 10.6 megabytes is its size. Now, what's happened is that in this particular case, we have a main partition that's 7 gigabytes in size, and then a secondary partition that's actually swap space, and that one is almost a gig, 975 megabytes. So that is that's the second partition, logical partition that's on this device. And the swap space is just extra space that we can use to swap if our memory fills up. So we can use that to swap memory back to disk and reload some more. This gives you the breakdown in both the devices, the volumes, and I'm going to list the block storage devices. That's my USB. Oh yeah. Okay, so I'm going to list the block storage devices, and we can see the very same thing. We have our SDA, which is the additional disk. It's actually not mounted. And then the second one, which is the 8 gig disk, notice that it has a mount point of the /, which means that that's the root. So this little slash here represents the file system. So this is the volume or the device or the disk, and then the file system point where that file system can be read is actually on this first logical partition of this second disk. So when I look at and I change directory to the root, and I look at the files, I'm actually showing you every um, element that is on that. Now we can't see that in a little more visual way, and there's a command called tree that I will show you, and I don't have it on this particular mininet distribution, but I do have it on my Windows subsystem for Linux. So I'm going to switch over to that real quick, and what we're going to do is we're going to look at the at a graphical way to see the files in the form of a tree, and this will give you a visual representation of the file system. Now, because I'm going to get a whole lot of data that's going to scroll by really fast, I'm going to go ahead and send this output of this command through what's called a pager. Okay, and so now you can see how as I descend into this folder, I'm actually showing you all of the files and devices that are there, files and folders. And I can keep going forever. There's a lot of files here, so I'm just going to press Q to quit. And that's a visual way to see those files. So, and again, what that kind of mirrors is when I'm looking at my Windows and I look at my C drive, which in this case Linux doesn't have drive letters. But when I look at that disk, and I go in there and I'm going to be looking at folders, and if I open that folder up, we'll be looking at more stuff, right? I can drill down, and that's that files and folders. This is my file system, and this is the root. Okay, right, and it's different than the actual devices and partitions. Okay, so we look at that. What do we actually look at when we connect to the system? If we have our file system and it's copied, we have a file system that actually reside on a partition. It could be a physical disk. It could take up the whole thing. It could be part of one. It could be a file on a regular drive. But there's a number of different ways to actually get that file system mounted. Now, if you remember this, what I told you is that when we were looking at this other system, and we said, oh, well, there's that other drive. Let me go right over here and do a quick screen share. And I said, oh, there's that other drive that we put on, right, that I made. That's mounted as the USB right here. Right, this was just a virtual disk file that I created and attached it. But remember what I said it wasn't actually mounted. So we don't have this thing mounted anywhere. So one of the things that we'll learn how to do is actually create an entry in the table, and then we can actually mount that drive, and we can read and write files to it. And that's really helpful if I wanted to make a volume and keep it and attach it to some different Linux systems. I can do that. So I'm going to show you one thing. Now, this is there are a couple of different things that we have in this case. Once I connect to this system, I'm actually looking at, in this case, that command line interface. I'm communicating to Linux with a shell. So the shell is this prompt that we see right here. But my interface is going through the TTY port. So I'll show you kind of what that looks like here. Now so the idea behind the different things here, we have a couple of different words that you may have never heard before. We have the shell, the terminal, and the kernel. So the terminal is the channel. So I may connect to the computer, to the Linux machine over the internet. I may use Telnet to connect. I may use Secure Shell to connect. I may use the console. And in this case, what I'm doing is I'm actually using the screen to see that system. And let me just go back to my screen share. When I look at my my Windows subsystem for Linux, what I'm actually looking at is I'm still using terminal 1, right? That's what that TTY means. It actually stands for, it's an old throwback to a technology where there wasn't a screen attached to the computer. It was a typewriter. So the TTY stands for teletype TTY. All right, and then now this particular Linux machine is a virtual machine in Windows, and when I look at my MiniNet that I use, that device is a virtual machine. But I'm connecting to basically a pseudo terminal. So, and I'm interacting with the shell through that terminal. So when I look at my processes and I list them, I can see terminal 1. Now, what I can do is, because I'm actually looking at a real system and I'm at the console, I can hold down Alt F2, and now I'm looking at a new TTY. So this actually represents TTY number 2. And I can log into that just like any other terminal. And if I list my processes, you'll see that I'm running terminal 1, a bash, and terminal 2, I'm running a bash. Now that is, so this is my first and my second terminal, and this is my shell it's a login shell that I'm running. Now, this bash shell is an actual executable program. It is an environment that I execute, and it maintains a state for me. It uses variables. It can interpret what I type. It's kind of fancy. It has special features in it, like auto completion. Right? I can type in the name of a command, maybe that starts with an L, and I can press tab. And that the feature of that bash shell is that it will go in and it will find all the commands that start with an L, and it will print them all for me. And that way I can make sure that I'm using the right one. Right? Other shells that are available, such as SH, the basic shell, it doesn't have that feature of auto completion. So if I type L and tab, I'm just going to get, it's going to work like a tab, right? Ultimately, what happens is my shell is the way that my system is able to interact with the terminal. So with the kernel. So when you look at this, this graphic here, you see the terminal is the conduit to get to the shell, and the shell is the program that interprets my commands and actually gets it over to the kernel, which is the core of the operating system. The shell is just a program, and I can have any number of shells, and I can even determine which particular shell a user or a particular login session will use. I can even write a script, and when I write a script, I can tell that script what shell to use in order to run the script. So that's why all of these things are very much in pieces, because it gives me flexibility. For example, my terminal, it could be um, it could be over a secure connection using a program like PuTTY. It could be over a telnet connection, which is unsecure. It could be a typewriter with a piece of paper stuck in it, a teletype terminal. But whatever that is, I have to interact with the shell. Now my shell can be a really fancy one, or it can be a really simple one. But I can choose those. So what we have that's a little bit different, and you may have, at this point be asking yourself, well, what exactly is a distribution? What is that? And so what that is when we take the kernel, that kernel that is capable of operating on any specific class of hardware, and we build around it things like application programs like shells and maybe different graphical user interfaces, and we start to make configuration changes and change what applications are installed already and configured. We've gotten enough components wrapped around this that it becomes a distribution. And so that is what we call the distribution, which is the combination of all of those different components, which would be the graphical user interface or desktop manager, the software components or applications, the shells, and then that's all wrapped around a specific Linux kernel. So each distribution is going to have its own, and sometimes its own different type of file system or file system structure. So if my distribution is a certain one, I may have certain directories that are present in certain areas. Different distributions are going to have different system schedulers that schedule the different processes that run on the operating system. And so there's really in the sense of distribution is one way to think about that is a type of customization. So it's what I am customizing that makes it what we say in the Linux world a different flavor. Unfortunately, we're not talking about food. We're talking about types of things. So I could have a whole class of operating system that is based on Debian or Ubuntu. And all those systems are going to have a very unique way of doing some of the same things. Now, they could look totally different. They could be made for different applications, but they have a common ancestry or heritage and a common way of the system working. So that's another important point of the distribution. So just going really quickly back in here, and we'll look at the shell. You got graphical user interfaces that actually run on top of the bash shell. And you can try this when you start your distribution. Go ahead and start it and log in, and then try pressing that Alt F1 or Alt F2. And if that doesn't work, try Control Alt F2. But I think usually the alternate F2 will work. When you hold down the alternate key and press F2, you should get a login prompt, and you can log in there. And again, here, this is where the regular user, you saw that dollar sign, that's the dollar symbol. And then if I elevate myself and become the root user or the user with supreme privileges, I'm going to have a prompt that looks like the hash sign. And that is letting me know that I have elevated privileges. If I'm not root, I might be root-like. Okay, and I'm going to need to be careful what I'm doing. Okay, so a couple things on this. Now, the command is otherwise known as a binary file, right? And so when we look at this command, and an example of that is when we use the command ps. And if I would say, if I would read that off, what I would say is ps-a. Okay, that's how I would read it. I would say ps-a. Now, if I did -help, I'm going to get a little help screen, and it's giving me a correction, tells me to type -help. But what I'm doing when I type in that dash in this PowerPoint, it calls it an option. In most cases, if you were to say option, you're going to get looked at funny. It's called a switch. So I might say ps-a, but I would call that -a switch, okay? Because I can use it and turn it on and off. Now, when I look at that ps-help, this is a little bit of a non-standard help, but it's really short. So it's telling me that when I use ps, I want to follow it with some option, okay? Otherwise known as a switch. So I could use the S for simple, L for list, O for output, T for threads, M for miscellaneous, or A for all. Now I could also type that. Alright, so I'm going to say ps-s, and I get a little more information about my processes. I'm going to do L for list. Normally I use ps-a for all. Usually ps big A gives everything, even the things that are not maybe not my own. But these are different ways to use switches. Output not really doing anything there, but every command has switches or options, and the reason why it does is because they're all programmed and everything is highly programmable. So another thing that's going to happen in the arguments are things that come after options, right? So these are going to be maybe like a file name or something else that I'm going to be giving that command actually some data or something to work with. And then I have this thing called a meta character. So the $sign indicates that I'm going to be using a variable. So variables can be numbered. They can also be words that I've defined. And then in this, a lot of times we'll use characters to actually protect other ones. So I'll show you an example of what that might look like. So when I'm in my shell, now we have a couple of different shells. This is the classic command prompt, which for Windows it is a shell. And if I wanted to actually go into that VirtualBox directory, one thing to notice in that directory is that the VirtualBox VMs has a space in it. And so that is what would be called a meta character. It's a character that basically needs to be interpreted differently. If I were to tell Windows that I wanted to go into that folder, in most cases it would see the space and say that it would throw an error. So I would use a double quotes on that command that would protect that space. On Linux, if I had a folder that had a space on it, I could either surround that name in single quotes, or I could use a backspace and proceed it with it, and basically what we call escaping it. So the shell would interpret it as a space. So I'll give you an example here. I'm going to go into my root folder, and I'm going to make a directory called Hello World. And notice that that actually created a directory with the single tick mark. So I'm going to remove that directory. I'm going to make one with double. Okay, and that actually put the backspace in the directory name, which is very interesting that it did that. Um, Now it's gone. So that is a way to use the space. Now PowerShell is another shell for Windows made in Java. And there's my VirtualBox VM folder. Notice that it put that folder in single tick marks in order to protect that space when I actually tab to autocomplete. So that's just another way of using the meta characters to protect things, and you'll see that often in special characters and other things that are there so that you can utilize all of them. And then we have different ways to, you've seen me use the manual pages, and I have a video on man and info that I'll post as well. But this is just an overview. I wanted to give you just some more information about the GUI, the command line, the terminal, the shell, and everything we talked about today. And this is so much fun. I hope you're enjoying what you're learning, and keep the questions coming. It will help me add content to the videos. So thank you very much.